Hi guys, how are you?
Pretty good, sir. And you?
Giving thanks, giving thanks, giving thanks. All right. Hmm. Where was I the last time again, Shamari? Please remind me.
I think I said we were going to be moving into first principles
First,
differentiation.
first principles differentiation, right? So I did some more piecewise last time around, right?
Yes, sir.
All right, cool. Thanks. I'm doing so many classes, I don't even know where I'm at. Um, I'm gonna see if I can find a question as a teaser before I move into wow. Hmm. All right, I'm seeing two questions here, but let me just project this one. As I do now, while I wait on the others to come in. I think they're coming in pretty slowly. All right, start working on that one for me, please. I'm gonna give you 6 minutes. I'll come back to you at 5:20. I'm gonna give you 6 minutes to work on this one. All right, so start for me, guys, please. Are we finished?
Not yet, sir. Attempting the last part of the question.
Last part of the question. All right, Papa, continue working. Let me see who else is here. Mario, what's the oh, oh, oh.
All right, sir, I just started, but give me like probably 5 minutes early.
All right, I'll give you another 5 minutes because since it's only the two of you, three of you here, I'll give you another 5 minutes to work on the question, please. Thank you.
Thanks, sir.
Matter of fact, let me ask you because that's what I'm doing now. All of you were okay with selecting calculus 1 for, wait, no, Jesus. Hmm.
And Canvas, sir?
No. I'm just thinking that I may have to give you guys override for calculus 2 as well so that you can get a billing for the semester. Did you all select calculus 2 for the for overrides?
Yes, sir, I did.
Yes,
All
sir. I
right.
think I have both of them selected.
Yeah, both of them selected already. Do me a favor because that's what I'm doing now for some other students. Some in another location. So do me a favor, all three of you. Send me privately your ID numbers. But also put your name there so I know who it is, whose ID number I'm picking up. So send me a WhatsApp now privately of your ID numbers. Let me just check the system to see if I find it so I can give you the override. All right? While you continue working on the stuff. So I'm moving from this computer now to go to another computer in another location. All right?
Okay, sir.
Cool.
Sir, in the WhatsApp group, you are teacher S? Sir? Anyone can answer that? Hello? You know, I should think so. I should think, sir, teacher S. As Shana, sir, last name, man. Yeah, hear me? Yeah, man, may I hear? Come on, I think so. Respect. Me, I send a message. Let me say ID number. Wait, sir, send no ID number in the group? No, private message. I hear him say send a private message with the ID number. I check if we registered to calculus too.
Your ID
Okay.
number and your name.
Okay. All right.
And that is seems a private WhatsApp message.
Yeah, man.
All right, all right.
All right, you must be finished by now. Are you?
Me attempt it no, sir.
Huh?
Me attempt it.
You attempted it. Yeah, that's it. That's the spirit, you know. I will never ever give you a question and say you must get it right at this stage of the semester. At this stage of the semester, when we're learning the stuff, I just want to give you an attempt to see exactly how much you have gained. So that is the spirit. Um, all right, let me hear what it is that we have for your answer. Um, all right. Shamari, go ahead, Papa. Go ahead.
So I have that it is not continuous at either of the points x equals 0 and x equal 1.
Okay. Thank you, sir. Mario, what say you? Amanda, what say you?
Sure, I still haven't completed it yet, you know, sir. Still trying to figure it out.
Have you done the first part? How much have you done so far?
All right. So how I work it out, sir? Well, I'm not sure how to answer the continuous part. So, sir, I got something. Maybe I got something totally different.
You got something what?
Totally different.
What did you get? That's what I'm asking you, sir.
Oh, the answer that I got?
Mm-hmm.
Oh, right. So for the first one, sir, I got 5/4.
Okay. And the second one you got?
So for the second one, sir, I didn't attempt it. Oh, and sir, I haven't completed the third one. I'm still.
All right. Adrian, how far you reach?
Sir, sorry to say, sir. Me never get to attempt it. Still at work.
Okay. Amanda, how far you reach?
Sir, I just joined, so I haven't attempted it.
Right. So when I would have substituted my values in it, I would have gotten 0/0.
Repeat that, please, sir.
I'm saying when I would have substituted my 0 into the function, I would have gotten 0/0.
Or the
So-
left of 0.
Right. So what I did was to factorize the numerator and to factorize the denominator. Remember, we're looking at the left of 0, The left of 0 is here. This is to the left of 0. But remember it says x is less than 0. So when it is less than, it is to the left. Hold on. So when it is less than 0, it is to the left. So what I'm saying to you is that when I substitute my value into the function, I'm getting, what I'm getting is 0 over 0 when I make that substitution. But I recognize that I can factor out x in the numerator, and I can also factor out x in the denominator. So I can do a simple factorization and cancellation to sort out my stuff. So you see, I factor out the x here. I factor out the x right here, so now I don't have 2x cubed, I have 2x squared minus 7x because I reduce this by 1 and plus 3. And then what is common in the denominator is 2x. 2x is common in the denominator. So I'm factoring out the 2x. And what is going to be left is x plus 3. So when I cancel my x's, now I can go ahead now and resubstitute 0 into the function. Because there was something in it preventing it from happening. So when I factor out my 0 now, I'm going to be left with 2x squared minus 7x plus 3. And now when I substitute my 0 here, that goes to 0. This goes to 0. So I'm left with 3 in the numerator. When I put in my 0 here, 0 plus 3 is 3. And 3 times 2 is 6. So this limit is actually 10 into a half. Look at that and tell me if you agree.
Sir,
No.
run that by me again. The 3 plus x plus 3.
Mm-hmm.
What you said that was 3 plus 0.
Yeah, because I'm
Or one.
substituting I'm substituting 0 into the function now. So it's going to be 0 plus 3. Remember, the function is 0.
So yeah.
Right.
So we take out the x and put 0.
Yeah, right. And then now you can have 0 plus 3 which is 3, and 3 times this 2 is going to be 6. So that's why I get the 6 here. And when I cancel this one, I'm going to get 1/2. Fair enough?
Yes, sir.
Yes.
All right. No. And that's what I'm saying. We're here to learn. It's a learning experience for us. So now that, let me ask a question. Can you all now see the error that you have made for this first part?
Yes, sir.
Mm-hmm.
So just a question based on my error. Whenever we get the 0 over 0, that's, I mean, from previous classes, that's indeterminate. So we should then go to factorize the terms. Is that right?
Correcto. You are not correct. Always remember that. What did you get for the value for the function to the right of 0?
Half.
All right. So is it continuous now?
Yes, it's very continuous now.
All right. Very nice. So there goes my statement. There goes my statement. So we're looking to the right of 0 for those of you who weren't there with the half of the second part. So Shamari, what you'd have done, you'd have lost the mark for up here, but you'd have gained the mark here. And what I would have done, I would have given you this mark down here, even though you had said discontinuous, because I would have given you the mark because up here was wrong and I penalized it up here already. So I want to penalize it down here again. because we are using the information from up here to answer this one down here. You see what I'm saying?
Yes, sir. I think I see what
Yeah.
you're saying.
Yeah, man. So that's how I mark. That's why I encourage my team members to mark as well. So when you look to the right of zero, this is going to be the function. And when you substitute your zeros in there, you're going to get 1/2, similar to up here. Now, you want to, all right, let me not give you any more time for that. So the other one now is to the left of 1, again, it's going to be 1 minus 4x over 3x plus 2. What you got for that value, for the limit?
-3/5.
-3/5. Anybody else got a value? Not going good enough because I can't give the question for about 40 minutes now. And it's only one person in the class talking to me. It's not good. Really not good. I got 1/2 again. Sorry, like. Tell me if you got that.
Yes, sir. That's what I got.
All right, good job. What about the rest of you? All right. Let's move on to the other topic. All right, so moving on to first principles differentiation. And your prerequisite knowledge for this topic is going to be your algebra. Your prerequisite knowledge is going to be your algebra. So my aim here is to differentiate 2x squared minus 5x plus 3 from first principles. Two x squared minus 5x plus 3 from first principles. Now, let me have a conversation with you. Shamari, can cook?
To one extent, yes, sir.
I bet if I call her mother and ask her, now she'll go say, "Sir, cook what?" True or false?
Mm.
All right, don't answer. All right. So let me ask you. So when you're cooking, you add the seasoning to if you're cooking, say you're cooking chicken, you add the seasoning to your chicken and them things, you don't. Your scallion and your thyme and your onion and maybe your sweet pepper and your pimento and your garlic, and your rosemary and them something. They don't add them something to it, don't.
Yes, sir.
All right, good job. That means you can cook then. And then now, when you're ready for share, what you do?
You're
You
all
eat the
spoon.
you eat the pimento, you eat the thyme, and you eat the scallion and the onion and the garlic and them something afterwards when you finish cook it out.
Oh, no, I say, because them incorporated in our chicken.
So oh, so them do the purpose already.
Yes, sir.
So what you do with them? You just scrape them out and do, you just dash them down. You can say yes, you know. If you say yes, you can cook.
One minute thing with that, we not dash them out, sir. Right? If they can eat, sir, right?
You eat the pimento?
Well, no, not the pimento, but every
You eat the garlic when it cook out? And you eat
no,
the
sir,
thyme?
no, sir, no, sir.
Oh, your friend me will like come like say, can't cook. So so some things, yes, like if you're doing like a stew beef and you use your sweet pepper to season up in the last part of it. You know, the sweet pepper, especially if you're using different color sweet peppers, they add color to the meat, and yes, they can be eaten, right? But things like the scallion now, unless it is that you're going to use the scallion to garnish, but when you cook out the scallion, you don't want that you don't want that to eat. No man, but bunny from it chin go right down to your
True,
belly.
sir.
Yeah, man. Yeah, man. And of course, definitely when you eat and you bite that pimento, oh God, it's the worst tasting something, but it make the food taste nice. The point is, similar to your seasoning of your pots. And when the seasoning would have done its duty, you take it out. Is exactly what it is that I'm doing with first principles differentiation. I'm adding some flavor to it. And when I'm finished adding the flavor, I'm going to remove it. So this is going to be my incremental change. My incremental change is my H along my X along my y-axis, and delta H is going to be the difference in the change of the stuff, right? So my H that is seen in the formula there is going to be my incremental change. What I'm saying to you is the formulation that I'm going to be using is the limit as h tends to 0 of f of x plus h minus f of x over h. What we do with that, we're adding h to the function, similar to how you add your seasoning to your pot to add flavor. When the seasoning would have done its duty, then you're going to remove it. Now, let me tell you something. When you go to a 5-star hotel, you will never catch a pimento in them rice and peas, or them curry chicken, or brown stew, or stewed beef. You will never catch any seasoning. Your cream of pumpkin soup, you'll never catch any seasoning like that. Because what they do, they have something that is called like a locket. And it is like think of two metal strainers come together, and it has a hook on it, and you hook it to lock in the seasoning. So you put in the seasoning in there, and you lock it in, and then you drop that in the pot and make that go and boil out, So the seasoning still in the pot, boil out and cook out and add flavor to it, But when the food finished, they're removing that locket. What do you think happened when they remove the locket?
When they remove the locket, the aftermath of boiling this of the extraction process, that is whatever happened to the pimento and the seasoning them come out with it.
Very good. So you're also removing all bits and pieces of the seasoning, so none is left in the pot. That's the difference between a 5-star hotel and a 3-star hotel and a 1-star hotel, 1-star hotel, you eat the food and you have to go pick out the pimento and pick out this and pick out that. No, man. Good hotel, you have to do them something there because they have them good stuff, and you do it. For the first principles, that's exactly what you have to do. You have to now go and pick out what it is that you would have put in, all right? So what I'm doing here, I have my function f of x. I'm adding my increment here. So when I add my increment here, then I'm going to remove my original function from it. So when I remove my original function from this f of x plus h, what is going to be left would be my function with my increments. And my increment is going to be my h. My increment is going to be my h, which is going to be, I'm going to sort out thereafter. So this is what is going to happen. Every time in the function I see x, I'm going to add a h to it. I'm going to add my increment to it. So watch me. This is going to become 2. See our x here? I'm going to open parentheses and put x plus h all square. See it right here, so all of this is my x. So every time I see my x, I'm going to add a x plus h to it. I'm going to add a plus h to it. Minus 5, see our x here? I'm going to call it x plus h. So you see all of this is my x, but I've added a plus h to it. And then my plus 3 stands alone. So let me go over this part again. Every time I see the function f of x, and I'm doing first principles, every time I call x, I'm adding a h to it. So you see this is going to be 2x squared. It's now going to become 2, open bracket, x plus h all squared. So because I see this x, I'm going to be adding an increment to it. See the increment here, plus h, and then I'm going to square it. Another x here is going to be minus 5, and then I'm going to add my increment, x plus h to it. And then I add my plus 3, see my plus 3 here. And then I'm going to subtract, see here? I always subtract. I'm going to subtract my f of x. I'm going to subtract all of this from it. Look at this. 2x squared minus 5x plus 3, see here? 2x squared minus 5x plus 3. What we're going to be required to do, this x plus h all squared is the same thing as x plus h times x plus h. It's the same thing as x plus h times x plus h. Now watch what I did. I'm recording something here, something fundamental. X plus h all squared is the same thing as x plus h times x plus h. Watch me with the multiplication. X times x gives me x squared. X times h give me hx. H times x gives me hx. And h times h gives me h squared. Let me do that again. Watch me. X times x gives me x squared. This x again times the other term in the bracket h gives me hx. This h times this x gives me another hx. And this h times this h gives me h squared. There's only one x squared here, so I write it back. And hx plus hx is 2hx plus h squared. Do me a favor. Take a minute and look through all of what I did so far right here. I'm going to hydrate. Take a minute and look through that for me.
Sir, question. If
I hear you.
so h x h still give a hx.
hx plus hx is x times h, you know. X times h is hx.
Oh, x times h is okay, sir.
You see it?
Yes, sir.
X times h is hx.
All right, sir. Thank
Yeah, no problem. Look at it. Another minute to look at it, please. Are you okay so far? Can somebody answer me, please? Are we okay so far?
Sir, I'll catch on everything. What do you think, sir?
No. I'm asking you, are you seeing what is happening so far?
Oh, yes, sir. With the with the multiplication of the signs?
Yeah.
Yes, sir.
All right, good. Now, so what I'm going to be doing is it is x plus h all squared. I'm going to substitute it for x squared plus 2hx plus h squared. See it here? X squared plus 2hx plus h squared. I'm making that substitution. And if you recognize everything else here, I rewrite it back right here. So agree with me or disagree with me. Let me know how you feel. Guys, answer me, no man, please.
Agree, sir.
Thank you. All right. So all I'm going to be doing right about now is just distributing the terms. What do I mean by that? I'm going to now expand. So 2 times x squared gives me 2x squared. 2 times 2hx gives me 4hx. 2 times h squared gives me 2h squared. Negative 5 times x gives me negative 5x. Negative 5 times h gives me negative 5h. My plus 3 stands alone. I write it back. There's an imaginary one between the negative sign and this bracket here, but I just put it there to highlight it now. The other questions I will not highlight it because I want to know that there's a, when I just have the negative like that, it's a one that is there as well. All right. So this negative 1 times 2x squared gives me a negative 2x squared. See it right here, so. And this negative 1 times a negative 5x gives me a positive 5x. See it right here, so. And this negative 1 times a positive 3 gives me a negative 3. See it right here, so. And you notice every time I carry my h in the denominator, my h and my h, notice every time I carry my limit as h tends to 0, the limit as h tends to 0, the limit as h tends to 0. Yeah, man. And then now I'm going to be at the point where I do some cancellation. Remember, everything from here, negative 2x squared plus 5x minus 3, all of these must cancel out. Remember, I tell you that the formula is minus f of x. So I am removing my f of x. I'm removing this. So watch me. See here? This negative 2x squared cancels with the 2x squared up top. The one here. So this one and this one will cancel. See it right here. So boom, boom. This positive 5x better have a negative 5x to cancel with. Let us check. See it here? Negative 5x. So I cancel this, boom, cancel that, bam. And then this negative 3 better have a plus 3 up top. Let us check. See it here? Plus 3. So I cancel those. Sir, is there anything else that is left to be canceled? No, because I would have used 1, 2, 3, my 3 terms on here. I'd have canceled it all throughout the numerator. What I'm going to be left with now is going to be 4hx, 2h squared, and minus 5x. See it right here? If I try now to perform the limit of the function as h tends to 0, this is going to be 0 plus 0 plus 0 minus 0 over 0, which is indeterminate. That's indeterminate. So I have to do a factorization. Uh-oh. But sir, this looks like the same question like what we did up top, where you gave us a piecewise function and we substitute, and it was going to 0, and when we substituted the 0 in the function, we got 0 over 0. And then you went ahead and did a factorization and canceled out, the x And when it cancelled out the x, we're able to find the limit to be a half. Anybody remembers that question?
Yes, sir.
All right. So now, similar to that question, I am now going to be canceling out my h. I'm factoring out my h. So because h is common in the numerator here, I'm factoring out my h. So when I factor out the h from h for 4hx, I'm going to be left with 4x, I'm sorry. When I factor out a h from 2h squared, I'm going to be left with 2h. And when I factor out a h from negative 5h, I'm going to have just negative 5. The h is cancelled. Then now I'm going to apply the limit. When I substitute 0, this here will go to 0. See it here, so? Boom. And I'm going to be left with 4x minus 5. And when I find the limit of that, I'm just going to get 4x minus 5. Because when I substitute 0 in there, there is no, this is now a constant. Because there is no h in that portion. So my answer is going to be 4x minus 5. I'll take your questions now. You know, I wish I could. Let me not say I wish. Let me try doing it. Hold on, please. All right. This thing not working out for me here. I don't know why it never normally work out for me. But can you see the screen? Oh dear, what is happening
Yes,
now?
sir.
Oh, hold on there. Oh, I don't know. Okay. I think there you go. Good. So now you have a full question on the screen. Look through it for me, please. Ask me whatever question you need to ask me. I'm right here, so ask me any question you need to ask me as it relates to this, because this question is on your mid-semester and it's going to come back on your final paper. Take your time and go through. Take your time and go through. Ask me the questions. All right. So I give you that time to look through it. Any questions? If you're not seeing something, please, me a beg you. Me a beg you. Ask me the question. If you're not seeing it, ask me.
All right, sir. So I have a question. You see,
Go ahead.
here, um, how did the second in the over the left side? How did the second bracket with the two x squared plus minus 5x plus 3? How did we get that, sir?
Where? Right here, say talking?
No, the other one. Other
Over
one
here,
not the
so?
square bracket. No, right there, sir, but the one not the square bracket. Yeah,
Or
how did we
this?
get that? Yes, sir.
So the function say f of x plus h minus f of x.
Yes, sir.
So see f of x here, f of x is equal to 2x squared minus 5x plus 3. So this is f of x plus h, and I'm now, see the minus sign here? Minus my f of x. So I'm minusing the f of x. So all of this here is the same thing as f of x up here. So talk truth.
Oh, yes, sir. All right, sir. Thanks.
Mhm. Any other questions? No other questions? All right.
No, sir, no question.
All right. I'm going to give you one to do, but I don't want to move that thing from the system, because it to remove open door, and I don't want that to happen. So I'm going to give you another question to do for me. All right. So I want you to differentiate for me 4x squared plus 3x minus 1 from first principle. So look at question 1. Question 1 said differentiate 2x squared minus 5x plus 3 from first principles. I am now asking you to differentiate 4x squared plus 3x minus 1 from first principles. 4x squared plus 3x minus 1 from first principles. You get that?
Yes, sir.
All right. I am going to mute. You have the solution for how I work the previous question. I want you to follow that example verbatim, and you should get the answer. You should get the answer. So go ahead for me, please. Start. On the mark, get set, go. Or is it going?
Good, sir.
Thanks much. Finish?
Not as yet, sir.
Sir,
Yeah.
Sean.
Yeah, man, I hear you.
All right, sir. We get the answer. I'm not sure if it's accurate. We'll get 8x plus 1.
All right. I will soon tell you. 8x plus 1. All right. Very good attempt. Anybody else? Mario? Sorry, Adrian? Adrian?
Sir?
You just told me
Sir?
8x. You just told me 8x plus 1.
No, not me, not me, not me.
All right, Mario?
Yes, sir.
You said 8x plus 1?
Yes, sir.
All right. Look through the calculation one more time for me, please. You're very close. I won't tell you where. I want you to find it. Look through the calculation, please.
Sir, on the exam, we go have formula sheet. We're going to
No,
get
sir.
formula sheet.
No, sir. No, no, no. Anybody else get an answer?
Yes, I got 8x plus 3
Check over that one more time for me, please. What was the function that I gave you? 4x squared what?
plus 3x minus 1.
Okay. So you are correct, Shamari. Mario, the rest of you check it over for me, please. I don't want to project the answer just yet. Very good, Shamari.
Thank you, sir.
See the answer there for the 8x plus 3. Shamari, I'm giving you past paper 2018 to do for me in the meantime. The rest of you, look over at the mistake that we made for that question for me, please. The answer is 8x plus 3. Shamari, you move on. The rest of you, look at that, the error you've made, please, and make a correction. Let me know if you see the error that you've made. The rest of you see it, guys. I don't like the idea of me talking to you and you're not answering me, I don't like it.
Sir, me I hear you, sir.
No, but me want to know, say, I am being heard. So when I ask a question, I want a response. How far are you, have you seen the error you've made with the first, with that question there, the second question there?
Yes, sir. I've seen the error. I forgot to my
Okay. Move on to 2018 past paper, please. Shamari, you finish this one?
Not as yet, sir.
Anybody finish the 2018 past paper? Amanda, can you unmute for me, please?
Yes, sir.
How far are you?
I haven't started it as yet.
Huh?
I haven't started it as yet.
Why?
Sir, I'm figuring out the one that we did before.
Why are you figuring it out? Do you understand it?
I understand it now.
Okay, all right. All right then.
Finish now, sir.
What's the answer?
6x minus 4.
Very good, my son. Proud of you. And I like your level of participation in class. I like what it is that you're doing. If you keep it up, there is no way you can fail the course. And the rest of you, I want you to take a page from Shamari's book. Comes to class, purpose-driven, always answer my questions, always completing the task. The rest of you have to find a way to be more engaging. Have to find a way to be more engaging. And I'm going to tell you why. I don't know if I'm being heard. Mario, was it Mario? No, somebody. Not, it wasn't Shamari, but somebody said, "Sir, may I hear you? But I don't know if you are hearing me." So when I ask if you're understanding, I want to find out if you are still around your device or it is that you are logged in and gone somewhere um, or something. I'm not hearing from the rest of you. And that's
No,
not
sir,
good.
it's me, so, sir. I'm actually online, but I still at work, so.
Fair enough. But what I'm saying to you though, Heslop, is keep in touch. You going to get busy at work because I understand say the work I have to go on because I have to pay the school fee and TT support and so on. I have to go feed the family and feed yourself. I understand all of that, But
Yes, sir, me have a plan. Me have a plan. Closer to, I just want to see the exam timetable, me plan to go up and leave. Because I know me I going miss out a 6 course me ever do in a 1 semester, sir. So me have to go do something.
oh Jesus. No, you tell me 6 courses, I start to worry. You know why? Because you are multitasking and sometimes getting distracted. So I don't want you to do these 6 courses and only pass 4. If you do 6, you have to pass 6. You can't even pass 5. You have to pass all 6.
So that's
So,
why me I got 30 days them straight leave.
so I'm
15 days.
so I'm saying though, the EducaSoft is not being completed. Remember, I'm saying this, and I will remind you as many times as necessary. Technically, I have a month left to finish off Calculus 1. I checked it on the calendar today. A month left to finish off Calculus 1. When you get that exam on that Wednesday or Friday, and I mark those papers over the weekend, and I submit those grades the Monday, any EducaSoft that is not yet complete, is not completed at the time, is going to be assigned as 0. That is going to hurt your final grade. Start working. A lot of times you students put yourself under pressure, make the work get hard because you procrastinate way too much. You have the work for do and say, yeah, man, I have enough time. I mean, time coming, recognize the blow, so much work you have to do, and you can't recover. So I want your participation in class. I want your commitment to finish up the assessments and just for you to do the preparations for the exams to come, mid-semester and final exam alike. I don't like how the thing are going so far. I'm gonna tell you the truth. I don't like where it's going because some of them now pull on a weight. But anyhow, and then a greater number now come out for class. Right about now, I say 3 students based on those who turn up on Monday, 3 students absent. But anyhow, have a good one. We'll talk on Friday. Bless up.
You
Yeah,
as well, sir.
sir,
Yes, sir.
you can send me the answer sheet for the 2018 process, huh?
Sorry, you can't send it a what?
The answer sheet for 2018 past paper.
It's not an answer sheet, it's just a question that I took off. Shamara was right, it's 6x minus 4. See there, you can take a screenshot of it.
Sure, will do.
Let me just, sorry.
Okay, done.
I don't know what I just did. Um, No, other side. Hold on. Hold on. Hold on. Hold on. 1 minute. See it there? No, hold on. All right. So you can take that screenshot of that. There's a 2012 as well that I want you to do for me. And you can check off number 3. That's my example for number 3. The negative 3x squared. So you can just take a screenshot of that page. I ain't going to work on those for me for Friday.
Right, sir. Thanks a lot, sir.
All right. We go later.